My name is Arjen Schwarz. I'm a lead DevOps engineer at Bulletproof, where I basically design and build infrastructures in the cloud. But right now, I'll be talking to you about serverless containers, what they are, how they work, how to use them, and most of all, why you would use them in the first place. So, the term serverless containers is two things. First, is serverless. Serverless is everywhere. Everybody loves it. We've heard many references to it already tonight. Julian over there with A Cloud Guru is always everything serverless. Sorry, Julian, Pete isn't here tonight, so I have to go to you. But then the other word is containers. And often what we see is it's serverless or it's containers. So how does it really mesh together? So maybe let's start a bit with some background. Go back to the old age, to the dark ages maybe, where we had to deal with something called hardware. Boo, boo, yes, indeed. Hardware was this thing that came in metal boxes. You had to put it in a data center somewhere. If you wanted to initiate a scaling action, that would take about 6 weeks, where you'd fill in some forms, have procurement, order your new box. It got set up in your data center. You'd go there, type things, you'd be happy, you'd go back to your office, and somebody would accidentally kill the SSH daemon, so you'd have to go back again. And I've been that somebody. So, but then we got virtual machines were a big improvement. So instead of just having a single piece of hardware where you would have one OS running on it, you could now have as many OSs and different types of them as well running next to each other on a single piece of hardware. So this would usually lead to bigger boxes. You'd, instead of single CPU, you'd have 64 or whatever you happen to do, and then you'd split that up into different virtual machines. In AWS land, we know these virtual machines mostly as EC2 instances. But we can still improve on that. So there was the containerization became more popular. It became especially popular once Docker released their more user-friendly way of it. So containers, for those of you not super familiar with it, are basically a way to package your application. But instead of just the application, you would package everything it needs. So this would be your libraries, any bits and pieces of an OS that you might need. But then underneath it all, it would use the underlying OS of either the virtual machine that it runs on or even the hardware if you run it directly in the hardware. This means that these packages, these containers, can stay nice and small. And most of all, a very important part of it, they are very portable. It's, again, a term we're all familiar with is build once, run anywhere. And that's basically the principle behind Docker containers, except it works. So this means the container can be small. And we saw earlier tonight, we saw Ross talk about how Envato is using containers as well. So that's definitely a good way to do things. But then how can we improve on this? Well, we can just get rid of the hardware and the virtual machines that are below it. And then we have our serverless containers, or as I like to think of them, serverless containers in space. Instead of just having your containers run on a piece of machine, imagine them floating up in space, not connected to anything, and only there when you really need them. So tethering maybe to something down at the ground, but that's it. Now, this is an AWS meetup, so it won't surprise you that I'll be talking about the AWS offering for this, which is called AWS Fargate. Fargate was introduced at reInvent last year. At that time, it was only in US East 1, which is fun and great, but for us here, it's often also less useful. Luckily, the team building this improved on it, and they gave it new features, but most importantly, they rolled it out into new regions so that in June, it actually came to Sydney, and we got to enjoy all the benefits of it. Now, Fargate is not actually a product in itself. It's more a part of a set of other products. So AWS offers two ways of orchestrating your containers. Container orchestration basically means that it's the tooling that you use to decide it goes on that piece of hardware or it gets deployed there, everything that comes around it and making the containers work together. So the two ways that you can do that in AWS are ECS, which is the Elastic Container Service, again, which is what Vado was using, as we saw earlier. It's a great way of doing things. And the other one is EKS, which is the ECS for Kubernetes. Now, EKS is also great. Unfortunately, it's not available here, so I'll leave that to the side for now. So how does Fargate fit into this? Well, basically, Fargate is a deployment method. So instead of saying, okay, I want to deploy my containers on these instances over here, you say, okay, I just want to deploy my containers. I don't want to deal with all the mess of having an operating system for it and managing my own instances. That's basically what it is. Now, let's have a look at a quick start at how we would use this. First, this is a very long process. It's 2 steps. This is step 1, the task definition. The task definition basically is where you describe what and how you want your containers to be deployed. So you say, okay, I want these containers to be deployed, and I want it to be running with this much memory, this much CPU. Maybe I want to be able to talk to them. Maybe I want them to be able to talk to each other. I want to open these ports, all of that stuff. And then the second step is you run up a service or task. Now, again, a task is basically an instantiation of a task definition, which means absolutely nothing. I know. So let's see if we describe it in terms that you might be more familiar with. How about a task definition is similar to an AMI. A task would then be an instance that you spin up from that AMI. So you define what you have, you spin up a single instance. But then a service is, again, one step further and is more like an autoscaling group. So you define how many of these tasks do I want to have running in parallel. You can set up autoscaling policies, you can have health checks, all of that you then set in service. So and just like with EC2, you can run things either by themselves as a task or as a service. Now, it wouldn't be fun if it didn't also show some badly cut off code. So here we have the same things I just showed, but as a couple of command line options. This is just using the AWS CLI. There's nothing special about it. We just tell it, use this Nginx container here, just the basic Nginx. A network mode of AWS VPC. This is something I'll go into a bit more in a little bit. It's a Fargate container, and we set a execution role. This is not the IAM role that allows you to grant your task access to other services. The execution role is the one that basically grants ECS access to actually spin up your container. Easiest way to get this one, in all honesty, is just once, the very first time you go into your account, just create a task, and AWS will make it for you. And from then on, you can just use it. You define CPU, memory. If you're used to ECS on EC2 instances, you may be thinking, okay, you don't need to always define that, but on Fargate, you have to define it at the task level already. In the task definition, I mean. And then you run your task. That doesn't work. Okay, you give it a network configuration, which basically means, okay, I want to have it deployed into these subnets, and I want it to have this security group, and I do or do not want to have a public IP. And again, you tell it to use Fargate, but it should be obvious. So, how does this then work? Just let's dive a little bit under the hood to see what these commands or this clicking in the console will actually do for you. Because in a way, we've got our container floating up in space, and we've got our VPC. So how does that actually connect? I mean, I told it to connect there, but how does it work? Well, to do that, the AWS VPC networking mode that I mentioned earlier, what it actually does is it spins up an ENI for you in your environment, where you told it in one of those subnets. An ENI is the Elastic Network Interface. This is the part of this is the thing that, for example, gives you an internal IP address. It's also what hooks up underneath your EC2 instances. If you spin up an EC2 instance, it will always have an ENI. This is just the network interface. It's how your compute power basically communicates to the rest of the internet, your VPCs, however you have it connected. So this all happens automatically. And as I said also, you can choose for it to have a public IP address. In this case, that would be an Elastic IP. It will always assign you a random Elastic IP as well. So it's not like you can say, oh, I want this one or that one. No, it's an Elastic IP. And going back to that ENI, one thing I forgot to mention before, it's pretty important. You get one ENI per task. So unlike, again, if we go look at ECS instances, ECS on EC2 instances, there you would usually have multiple tasks running on the same instance. And and they would all share the same IP address. But here you only have the one IP address per task. This has a number of consequences. You'll definitely have to pay attention to things like scaling actions and your subnet sizes. If you suddenly scale this to 100 tasks running in parallel in a tiny subnet, you'll have a problem. Same with service limits and things like that. And the other thing then is it's not just limited to, it's limited to the IP, but it also, the other thing there is there's a limitation on your ports. So if you use to ECS on instances, you can have multiple tasks running that have the same IP address. You can have multiple containers within a task that listen to the same port. So you could have, for example, 2 Nginx containers running, both listening on port 80, and you'd have them magically translated to something in the in the range that AWS provides for you, which is somewhere between 31,000 and 65,000 randomly assigned, and your load balancer will do the translation for that. It doesn't work here, so instead what you get is you always can only have a single port open. Or not, each port has to be unique. Let's leave it at that. Now, as I said, you can still hook it up to a load balancer to go out to the internet. But then we come to a different question. Why would we want to use that? We have so many compute options. We have our EC2 instances. they are useful. We have our Lambda functions. They're great, even if you shouldn't run them for 15 minutes. And we have ECS and EKS just using those instances. It's all good. So why do we really want to have more options like that? Well, in a way, obviously, more options is good. But let me use this really very, very unscientific graph here to explain it a bit. So we've got an average runtime and a maintenance requirements here on these two axes. In the upper right corner, it won't surprise people, we'll have EC2 instances. EC2 instances, they usually run for a very long time. It can be days, it can be weeks, months, or even years. And in the meantime, you have to nurture them, feed them. You can do this in an automated way, where you will constantly just build a new AMI, replace it, which obviously is the way you should do it. Don't try to have an actual pet and feed it and nurture it. That's nice at home, but not with instances. And on the other hand, then, this Lambda runs for a very short time and doesn't take much maintenance. So obviously, if you've run a Lambda function, you will actually know. You've probably, the only times I ever have to deal with them is when AWS sends me an email and says, hey, you used Node.js for an old version of your app. Can you please upgrade this one now, because we're no longer supporting not just 4 or 6 or whatever number they released this week. So that's easy. But then on the other, still over there, we have ECS on EC2 instances. Not quite as bad as an EC2 instance by itself, because usually we don't care as much about what is running on the instance itself. So with ECS, you can more easily just use the AWS provided ECS optimized images, run those, and all you really care about is whatever is on your Docker containers. But then that means we can have Fargate in more on this side, where we don't have to care about all of that at all and only care about our containers. Sure, they will still need some maintenance. You will still need to update libraries in your containers, but you would usually do that as part of a development process. You do it locally. It's not something you have to go out to do maintenance on your infrastructure for. So it's part of the application instead. And I can draw a lot of these kinds of graphs for you. And I can make anything I want to look wonderful. And I'm sure most of you can do the same. I could say, yeah, EC2 is great for this. Lambda is awesome for that. Use Fargate here, or it's just an EC2 here. In the end, what it really comes down to, as always, is to use the right tool for the job. So what I'm now trying to do for the next couple of minutes is show you some instances where Fargate might just be the right tool for the job for you. So very first option there is just your standard workloads. Nothing exciting about this. But say you have a web proxy. While the video is playing, it's basically just, okay, I explained this already. I just start things. I give things a name, select the VPC subnets, a security group. Even if you do it through the console, a security group that listens to port 80 will automatically be created for you. You can add load balancers. Didn't do that in this case. But in the meantime, it already has these two proxies up and running. Well, not quite running yet. It's still provisioning. But in a couple of seconds, you can see it now activating, which basically means it's done. Right? And that didn't take long at all. And this was obviously through the console, which is not, as most of us will know, not the most efficient way to quickly spin up multiple things. Simple, easy. I would even say it's just boring. Right? But then, this is infrastructure we're talking about. Boring is very good. Boring, it's simple, it's predictable, it's stable. Most of all, boring means that I don't get a phone call at 3 o'clock on a Saturday evening when I would much, much rather be having fun. So that's one thing, just use it the boring way. Another way is on demand. Again, it's a serverless tool, so we can easily create things on demand with it. And remember here, we can deal with the entire AWS ecosystem. It's not just limited to, oh, we have to use Fargate or this or that by ourselves. Again, looking back at our earlier presentation by Envado, they're using everything together to get the great solutions that they built. So one example of this with Fargate is something I built shortly after Fargate first came out, and I actually presented about it here half a year or so ago, I think, which is a Bastion on demand. Basically, what this allows you to do is spin up a Fargate container in your environment that you can SSH into, and that gives you access to the rest of your environment. We'll know Bastions or jump boxes, whichever name you want to give them, that you would have running all the time and have to SSH into. Now, in all fairness, 2 months ago now, I think, AWS released something called the Session Manager, which basically makes this idea redundant. But the underlying principle of it still is still there. So how does it work? We have an API gateway that we make a call to as a user. This in turn calls a Lambda function, and all that Lambda function does is it creates the security group, a security group, obviously in this case tied to the IP address I made that call from. And then it will create my, Fargate tasks with its ENI, and I can SSH into it. It's super simple, and it's there when I need it. And you can have a similar endpoint using a curl x delete to get rid of it again. It's there when you need it, it's gone when you don't need it. Simple. And then of course, we can use scheduled tasks. So we're all familiar with these things, Cronjobs. Cronjobs are great. They've held a lot of tools together. Whether you needed it to run your daily scripts, or once in a while restart your Apache server because it would run out of memory if you didn't do that. There are many ways that you can use it, there are many things that you can use it for. But things have changed. What worked back then on a single server might not work as well when you have an autoscaling group. And in an autoscaling group, each of your instances will have the same cronjobs. You don't really want to run that invoicing task 3 times at the same time. You only need it done once. Or even, imagine a scaling action happens while your cron job is running, and suddenly halfway through your cron job, the server it runs on disappears. It's also not a very good case. So the common way to solve this has always been to build a cron server. These cron servers would usually run for a very, very long time. I mentioned it earlier, EC2 instances, you just have them running, and especially when it comes to things like this, they will often become manually managed. Somebody logs into them, updates the cron tab, and on and on and on, maybe installs some dependencies that are needed for this particular cron job, and it keeps going. So instead of that, let's just get rid of that and replace that with actual cron jobs. Just run each individual cron job as its own Fargate task. Basically allowing you to not only have these tasks be more specific to your needs, they're only there when you need them. And it's easy as well. You create your Docker file, you install any libraries you might need, you add your script to it, and then in the console, or however you want to do it, it says schedule tasks. You run it just from the regular Cronjob schedule, or instead maybe you say, okay, I want to run it every X minutes. So it makes it a lot easier. Now, another thing that I always find important when seeing whether something is or is not relevant to me are its limitations. And obviously, Fargate has its own limitations. So one of these is there's no IPv6 support yet. How important this is in your case, I don't know. And it can be important or not. And I'm sure that it's something that AWS will be working on. Another one I already mentioned is the one IP per task. Pay attention to your subnet sizing, pay attention to reports, all of that. And it's a serverless tool, so a serverless resource. So you have less control. It's not running, you don't have control over things like Docker plugins that you might want to use, or file system plugins. None of that is under your control. Similarly, then, your data storage. It's running on computers managed by AWS with hard disks managed by AWS. If you want to make sure that your data is still there when next you run a task, store it somewhere else. And there's no Windows support for however much that is a limitation. Of course, I can put advantages against this. Less control means low maintenance. You don't need to deal with maintenance issues. You don't need to patch the underlying OS. You don't need to deal with whatever processor vulnerability comes up next. Same for security. AWS takes care of a lot more for you. It's a serverless thing, so you pay as you go. Only quickly start something up, quickly tear it down, and that's all you have to pay for. But unlike something like Lambda, you do have the full power of containers here. This can be anything. You can install the libraries you need, but most importantly, you can run any language you want. If you like Erlang or even Ruby, you can run it in a container, whereas you'll have to wait until AWS will support it in Lambda. And it runs longer. And it's designed to run longer. It's not like Lambda running for 15 minutes is great when you need it, but this could run for 15 hours if you really needed to. So, to sum it up, basically, when is Fargate or Space Container the right tool? I gave you a couple of options, a couple of possibilities. First is if you really care about the ease of use. And so it's not just click, 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 easy. It's also your people, whether it's you or somebody else, can spend the time doing more interesting things than instead of maintaining the infrastructure. We can build things on demand, just spin it up when we need it, get rid of it afterwards, or automate that using scheduled tasks. But of course, the most important thing is always your idea. I don't know what your architecture is. I don't know what your needs are. But I do hope that this talk at least gave you some idea of what you can do with it and maybe how you can use it in your environment. So, as our friends at AWS like to say, go build, but do it in space. And with that, thank you for listening.
Cool. Do we have any questions for Arjen?
Thank you. Thanks for that. That was good. What's the average sort of cold start time you're seeing on Fargate?
It depends on the container, obviously. Usually it will be between 30 seconds, maybe a minute. Before it came to Sydney, I actually would I would try and spin up things in US East 1, and you could clearly see when the East Coast in the US woke up, because from about 9 p.m. here, it would suddenly take a couple of minutes to get one started up. It's not as much a problem now, so generally it's 30 seconds, maybe a minute.
Cool. Thanks. Yeah, no, I can't remember if I played with it in Sydney or in US East, but I was seeing like 1.5 minutes to 2 minutes. It's good if they're getting that down. Cheers.
Yeah.
Any more questions, guys?
Over there.
Can you attach an EBS volume to a Fargate task?
You can't, unfortunately. I'm thinking maybe, I haven't actually tried it, but one thing that I've been meaning to test is if you can at least just mount an EFS endpoint, because that is basically just you need SIFS driver or the EFS driver running, but I haven't actually had a use case for it yet, so I never got around to trying it.
So Arjen, I just wanted to ask you, like, if you had to pick a AWS newsletter to subscribe to on the internet, of the whole internet, if you could just give me some advice on what I should be subscribing to, that I'd love to know, like your thoughts.
How nice of you to ask. There is one here, actually. The slide behind me at the top is my website. I write more or less a weekly newsletter with news and updates. It's not just AWS, but most of it is AWS. It will also have blog posts. And I will be writing a blog post about what I just spoke about. I've been meaning to do that for several weeks now, after I've gave this talk at various conferences. But it will show up soon, so go there. You can subscribe to it or not. That's completely up to you. But thanks for the plug, Chris.
Is it applicable to the blockchain, for example? Maybe like starting up like a testnet type thing they could set up on the side?
You can use it for anything you want to, really.
Okay.
It's, as I said, it's quite easy, and anything you can do in Docker, you can, well, not anything because it has some limitations, as I pointed out earlier. But yes, you can run things like that.
Cool stuff. Thanks.
Any more questions, guys? No? Thank you very much.
Thanks, guys.